Hello and welcome to my channel. In this video we are going to solve 9 questions from Cambridge IGCSE Mathematics Paper 4 Extended, Variant 4.1 from May-June 2024. So let us start with the first question. The first question is from Numbers chapter. The table shows the areas in kilometers square of the 4 largest rainforests in the world. So we can see in the table some rainforests have been named and on the right hand side their respective areas are given. The first sub-question is, find the area of the Valdivian rainforest as a percentage of the area of the Amazon rainforest. Since here area of the Valdivian rainforest is given as a percentage of area of Amazon rainforest, we are going to write it as area of Valdivian over area of Amazon rainforest times, since it is asked as a percentage, we are going to multiply this fraction by 100. Now let us substitute these values using the table. So area of Valdivian rainforest is given as 250,000 and area of Amazon rainforest is given as 5,500,000 times 100. So this will give us a value as 50 over 11, or as a decimal we can write it as 4.545. So we have written here 4.545%. Now let us look at the second sub-question. Write in its simplest form the ratio of the areas of rainforests Valdivian is to Atlantic is to Congo. So here basically we have to write the respective areas of these rainforests as a ratio. So we are going to make use of this table and write the respective values of the areas. So we have here. So the area of Valdivian rainforest was given as 250,000 in the table. Now area of Atlantic is 1,315,000 and area of rainforest in Congo is 2 million. Now here we are going to begin by simplifying these numbers, starting with cancellation of 3 zeros from all the 3. So we can divide each of these numbers by 1000 and cancel them off. So this will simplify as 250 is to 1315 is to 2000. Now each number is ending with a 0 or a 5, which means these numbers are divisible by 5. So we are going to divide each number by 5. So here 250 divided by 5 will give us 50. 1315 divided by 5 will give us 263 and 2000 divided by 5 will give us 400. So here we have reduced the fraction and written it as 50 is to 263 is to 400. Now this cannot be simplified further. So this is the simplest form of the given ratio. Now let us move on to the next sub-question. The Amazon rainforest has 60% of its area in Brazil and 10% of its area in Colombia. 43 1/3% of the remaining area of the rainforest is in Peru. Find the percentage of the Amazon rainforest that is in Brazil, Colombia and Peru. So let us say that the total area of Amazon rainforest is 100%. So out of 100%, 60% of its area is in Brazil, which means minus 60. So 60 is gone in Brazil. Now 10% of its area is in Colombia, which means again minus 10. So this belongs to Colombia. So total area of Amazon rainforest was 100. Out of that 60% is in Brazil and 10% is in Colombia. So the remaining area of the rainforest is 100 minus 70, which gives us 30%. Now it is given that 43 1/3% of this remaining area of the rainforest is in Peru. So we are going to write here percentage area of Amazon rainforest which is in Peru is 43 1/3% of the remaining area, and the remaining area is, we can write here 30, or we can just write it as 100 minus 60 minus 10. And this is 43 1/3%, so I have divided this number by 100. Now let us see how much value we get here. So this will give us 13%, which means 13% of the total percentage area of Amazon rainforest is in Peru. Now the question is, find the percentage of the Amazon rainforest that is in Brazil, Colombia and Peru, which means we have to add the given percentages which is in Brazil, Colombia and Peru together. So we get the total percentage as 83%. Now let us move on to the next sub-question. The area of the Amazon rainforest represents 27/50 of the total area of rainforest in the world. Calculate the total area of the rainforest in the world and give your answer correct to the nearest 100,000 kilometers square. Now here we have to make a mathematical equation using this given statement. So the statement is area of Amazon rainforest represents or is equal to 27/50 of the total area of rainforest. So we have written it as a mathematical equation now. Area of Amazon rainforest is equal to 27 over 50 times, because 27 over 50 off is given. If off is given in mathematical terms, it is multiplication, is multiplied with total area of the rainforest in the world. Now area of Amazon rainforest was given in the table as 5,500,000. So we have substituted its value over here is equal to 27 over 50 times total area of rainforest in the world. Now we are going to take this fraction on the right hand side. So this fraction flips upside down when we do that, and here we get 5,500,000 times 50 over 27 is equal to total area of rainforest in the world. So this will give us a value as 10,185,185.19. So this is what we have written over here, kilometers square. And since the answer is asked to the nearest 100,000 kilometers square, we are going to round it up to the nearest 100,000. So the nearest 100,000 to this value is 10,200,000 kilometers square. Because 185 is nearest to 200, we have rounded this value to 200. Now let us move on to the next sub question. In the world, 60.7 hectares of rainforest are lost every minute. Calculate the total area in hectares of rainforest that is lost in 365 days. Give your answer in standard form. Now here it's given that 60.7 hectares of rainforest are lost every minute. So we have to find out how much total area in hectares of rainforest is lost in 365 days. So we have to convert this 365 days in terms of minutes. Now in one day we have 24 hours, and we know that every hour has 60 minutes. So we are going to represent those 24 hours in terms of minutes. That is, multiplying 24 times 60 minutes will give us 1440 minutes in a day. So in one day, if there are 1440 minutes, then in 365 days, how many minutes do we have? So we have to just follow the cross multiplication method here. So we are going to multiply 365 with 1440 minutes, giving us 525,600 minutes in 365 days. Now here, every minute 60.7 hectares of rainforest is lost. Then in 525,600 minutes, let us see how much area of this rainforest is lost. So here again cross multiplication method can be used. That is, in 1 minute if 60.7 hectares of rainforest is lost, then in 525,600 minutes, how many hectares of rainforest is lost? That is, again cross multiplying these two numbers, we get the value as 31,903,920 hectares. Now it is mentioned that we have to write the answer in standard form. So here take the first two digits and write it as 3.1, put a decimal over here, and when you put the decimal point over here, just count how many digits come after the decimal point. So here if you count, you get 7 digits. So we have written here 3.1 times 10 to the power of 7 hectares. Now this is in the standard form. So this much area of rainforest is lost in 365 days. Now moving on to the next sub question. The Amazon river has length of 6,440 km. Correct to the nearest 10 km. The Congo river has a length of 4,400 km. Correct to the nearest 100 km. Calculate the upper bound of the difference between the lengths of Amazon river and the Congo river. Now let us first come to this Amazon river, where we have to find out the length of this river nearest to 10 km. So take this number which they have given and divide it by 2. So this will give us a range, like 10 over 2 is plus or minus 5. Which means we need to add 5 to this length and subtract 5 to this length. When you add 5 to this length, you get the upper bound, and when you subtract 5 from this length, you get the lower bound. Now we are going to do the same thing to this Congo river. Since it is given nearest 100 km, we are going to take 100 and we are going to divide it by 2 to get the threshold. So here we get plus or minus 50, which means when you add 50 to this length, you get the upper bound of this river, and when you subtract 50 from this length, you get the lower bound of this river. So let me write here. Now Amazon river, the length is 6,440 kilometers. So I have divided into LB, which is lower bound, and UB, which is upper bound. Now when we add 5 to this number, we get 6,445 kilometer, and when we subtract it, you get the lower bound as 6,435 kilometer. Now using the same thing, I found out the length of the Congo river. So when you add 50 to 4,400, you get 4,450. And when you subtract 50 from 4,400, you get 4,350 kilometer. Now this becomes important. we have to find out the upper bound of the difference, which means we have to take the upper bound of Amazon River because its value is more than Congo River, and we have to subtract the lower bound of Congo River with the upper bound of Amazon River. So I have written here upper bound of the difference is upper bound of Amazon River minus the lower bound of the Congo River. Now if in the exam lower bound was asked, then we were going to use the lower bound of Amazon River and we were going to subtract the upper bound of Congo River from the lower bound of Amazon River. Now here we are going to take the upper bound of Amazon River, which is 6445, minus the lower bound of Congo River is 4350. Now subtracting these two, we get the value as 2095 kilometer. Now this is the upper bound of the difference between the lengths of these two rivers. Now let us move on to the second question. Now the second question is from Transformations chapter. On the grid, draw the image of the triangle T after a reflection in the x-axis. So here we have been given the x-axis and the y-axis, and the triangle T is given. We need to reflect this triangle in the x-axis. So here let us just mark the vertices of this triangle. Now this vertex is at a distance of 1 block from the x-axis. So its reflected point is also going to be at 1 block from the x-axis. Now looking at this point is at a distance of 3 blocks, 1, 2 and 3 from the x-axis. So its reflection is also going to be 1, 2 and 3. It's going to be over here. This point is also at a distance of 3 blocks from the x-axis. So its reflection is also going to be over here. Now once we have got all the reflected points, we are just going to join them and write their coordinates. Now we have the x coordinate of this point as 5 and y coordinate as 3. Now for this point it is going to be 2, 1, and for this point the x coordinate is 1 and the y coordinate is 3. So this is the reflected triangle along the x-axis. Now the second sub-question is the triangle T after a translation by the vector -5, -2. Now this is a column vector in which -5 represents the direction of x and -2 represents the direction of y. So if x is negative, we are going to move towards the left, and if y is minus, we are going to go downwards. So we have to just move this triangle to the left by 5 units, and we have to then move it down by 2 units. So let us come over here and translate it. Now let us again consider these points, starting with this one. First we are going to move it left by 5 units and down by 2 units. So 1, 2, 3, 4, 5. And going downwards 1, 2. So it comes over here. So this point has come over here. Doing the same thing for this one, 1, 2, 3, 4, 5. Now we have to go downwards by 2 units, 1, 2. Now the last point, it should be over here because this point and this point are in the same line and the distance between these two is 4 blocks. So you can just mark it over here. Now let us join the points. So it's going to be this way. So this is translated. Now let us write down the coordinates. For this one, the x coordinate is going to be -3 and the y coordinate is going to be -3 again. Now for this point, it is going to be the x coordinate is 0 and the y coordinate is going to be -5. And this point, the x coordinate is -4 and the y coordinate is -5. Now moving on to the last sub question. Triangle T after an enlargement by scale factor -1/2 with center -1, 1. So let us mark -1, 1, the center for the third one. So it is going to be over here, -1 and 1. So this is our center. Now here for the enlargement, I have drawn 2 lines as you can see through the vertices. Let me label the vertices over here. Let me take this as A, this as B and this as C. Now after drawing the 2 lines, I have just marked the coordinates of the enlarged points. Now let me explain how I have got these points. They have mentioned that the enlargement is by -1/2 scale factor. Now this is a fraction, so remember the enlargement means whatever object they have given over here, it is going to be smaller since this is a fraction. And this negative sign emphasizes that the enlarged image is going to be on the other side of the center. Now this was our center, and on this side of the center we have our object, so its enlarged image is going to be on the other side of the center. Now you have to measure the distance from the center to the vertices. For example, let me just show you for the point C, it is easier. Now from the center to point C, it is approximately 4 units. So from the center, since the distance is approximately 4 units, I'm going to multiply this distance with its scale factor. That is 4 times 1 over 2. That is going to give me 2. Which means that from the center, the enlarged point is 2 units away. So as you can see, this is the line which is being traced from point C. So it goes this way. So going through like this, from the center, 2 units away comes its image. So let me write it as C dash. Now using the same format, we are going to measure the distance between the center and the point A. You can use a scale for this and then divide it by the scale factor. So for example, if this is approximately 3 units between the center and the vertex A. So if it is 3, then you are going to multiply with its scale factor 1 over 2. So that is going to give you 1.5. So here now tracing the line which we have drawn. So it should go this way to mark the vertex of the image A. So we are tracing this way, and from the center it should be 1.5 units away. So you can keep a scale and mark here 1.5 units away. So our point of enlargement for A becomes A dash. Now to mark the point B, as we can see AB are in the same line, you can measure the distance between the points A and B. Approximately, for example, if it is 3 units, we are going to again multiply the 3 units with 1 over 2, giving us again 1.5. Which means from A dash, you're going to take 1.5 units away and you're going to mark the point B dash. So this is going to be the enlargement of the given triangle. Then join the points. So when you mark it this way, these are going to be the coordinates of the enlarged points. Now moving on to the big question. A shape P is enlarged by scale factor 3 to give shape Q. Shape Q is then enlarged by scale factor 2 over 5 to give shape R. The area of shape P is 10 centimeters square. Calculate the area of shape R. Now let us try to understand this example by using a formula. The formula we are going to use here is area of new shape that is going to be formed is equal to scale factor square of the old shape times area of the old shape. Now here a shape Q is being formed. This is a new shape by using the shape P, by using a scale factor K, for example. So if you want to find out the area of this new shape, you have to multiply the area of the previous or the old shape with the square of its scale factor. Now area of shape Q is equal to the scale factor of shape P is given as 3. So we write it as 3 square times area of the previous shape or area of the old shape as area of P. Now area of P is given as 10. So we write 3 square is 9. So 9 times 10 gives us 90 centimeters square. So we got the area of Q as 90 centimeters square. Now in the next statement they have given shape Q is then enlarged by scale factor 2 over 5 to give shape R, which means we are going to get a new shape R using the previous shape Q, and to do that we are going to make use of the area of shape Q and multiply it with the square of its scale factor to get the area of the new shape. So here we have written area of shape R is equal to 2 over 5, that is the scale factor of Q. So we are squaring it times area of Q. So 2 over 5 square gives us 4 over 25 and area of Q we had got it as 90. So area of the new shape R is equal to, when you solve this you'll get it as 14.4 centimeter square. Now let us move on to the next question. The third question is from Algebra. C is equal to 1 over 4 times x times y square. Find C when x equal to 5 and y equal to 8. So here we need to just plug in the values of x and y in this given equation. So we get 1 over 4 times, in the place of x we have written 5 and in place of y we have written 8. So 8 square. So it becomes 1 over 4 times 5 times 8 square is 64, and simplifying this we get the value of C as 80. Now here in the next question, find the positive value of y when c equal to 15 and x equal to 2.4. So here we need to find out the value of y, which means we have to make y as the subject. So c equal to 1 over 4 times x times y square. Now the first step would be to send this fraction 1 over 4 on the other side of the equal to sign. So 4 goes on the left hand side and multiplies with c, giving us 4c is equal to x times y square. Now we are going to send x on the other side of equal to sign. So we have written here 4c over x equal to y square. Now the next step is sending square on the other side of the equal to sign. So we have here y is equal to plus or minus square root of 4c over x. Now remember that square becomes square root when you send on the other side of equal to sign, and it changes to plus or minus. Now here in this question they have asked us to use only the positive value of y. So we are going to discard the negative value and consider only the positive value. So we have here y is equal to plus square root of 4c over x. Now here we need to just plug in the value of c and x in this expression. So we have here square root of 4 times 15 over 2.4, and this will give us the value of y as positive 5. Now the next question is write as a single fraction in its simplest form. Now we can see that two fractions are given. Now to change this into a single fraction, we are going to make use of the cross multiplication method. So here 2x plus 5 multiplies with the numerator 4 and x minus 1 multiplies with the numerator negative 3. So we have shown here 4 multiplies with 2x plus 5 and negative 3 multiplies with x minus 1, and then the denominators will multiply together. So here we have multiplied the denominators. Next, expansion of these brackets in the numerator. 4 multiplies with 2x giving us 8x. 4 multiplies with positive 5 giving us positive 20. Negative 3 multiplies with x giving us negative 3x. And negative 3 multiplies with negative 1 giving us positive 3. Now you can keep the denominators as it is or expand them. Here in this case I have just kept them as it is. Now once we expand this, we are going to gather the like terms in the numerator. So 8x and minus 3x are like terms. So when we add them, we get the value as 5x, and 20 plus 3 gives us 23, and the denominator is kept same. So here we have changed the two fractions into a single fraction format. So this cannot be simplified further. So this is going to be our final answer. Now the C part of the same question. Expand and simplify 2x plus 3 times 4 minus x the whole square. Now here the first step is just spread out the given brackets. So here we have written 2x plus 3 and 4 minus x the whole square is written 2 times. Now to simplify this, we are going to consider only the first two brackets and going to expand them. So here 2x multiplies with 4 giving us 8x. 2x multiplies with negative x giving negative 2x square. Positive 3 with 4 gives us 12. Positive 3 times negative x is negative 3x. Now this thing multiplies with 4 minus x. Now next, gather the like terms from this bracket. So 8x minus 3x gives us 5x minus 2x square plus 12. Now this multiplies with 4 minus x. Now again expansion. 5x times 4 is 20x. 5x times minus x is minus 5x square. Minus 2x square times 4 is minus 8x square. Minus 2x square times minus x is plus 2x cube. Finally, plus 12 times 4 is 48 and plus 12 times negative x is negative 12x. Now the final step is simplification and writing the answer. Start by writing the highest power of x first. So 2x cube, this is the highest power of x. So we have written 2x cube. Next is negative 5x square and negative 8x square. When you add them, you get negative 13x square. 20x minus 12x gives us positive 8x. And finally, writing the constant, we have plus 48. So this is the simplified answer of the given brackets. Simplify y to the power of 8 over 16x to the power of 16. The whole thing is raised to the power of negative 3 over 4. Now for these kind of questions, first make sure that you are changing this negative power into a positive power. So here we do that by flipping this fraction upside down. So 16x to the power of 16 becomes the numerator and y to the power of 8 becomes the denominator. So here you can see the negative power has changed into a positive power. We can do this by using the laws of indices. The next thing is this power gets distributed to each term within this bracket. So here the power 3 over 4 goes to 16. You can see here 16 to the power of 3 over 4. 3 over 4 also goes to x to the power of 16. Divided by, it goes to the denominator also separately. Next, 16 can be written as 2 to the power of 4. So we have written here 2 to the power of 4 raised to the power of 3 over 4 times x to the power of 16 times 3 over 4. Now again using the laws of indices, the power raised to another power, the powers will multiply together. Divided by, using the same law, we are going to multiply the powers for the y. Now This is also 4 times 3 over 4. So 4 from the numerator cancels 4 from the denominator. Now here 16 and 4 in the denominator divides 16 in the numerator. That is 4 1 times and 4 times is 16. And here 4 1 times is 4 and 4 2 times is 8. Now simplifying this, we get 2 to the power of 3 times x to the power of 4 times 3 is 12 over y to the power of 2 times 3 is 6. Now 2 cube is 8. So we have written here 8 times x to the power of 12 divided by y to the power of 6. Now this is our final answer. Now the fourth question is from Statistics chapter. Jianyu records the time in seconds that some cars take to travel 195 meters. The box and whisker plot shows this information. So here a box and whisker plot is shown, and here the x-axis represents the time. So here it means that a car has taken 6 seconds to travel 195 meters and another car has taken 13 seconds to travel 195 meters, and this line represents the lower quartile, this represents the upper quartile, and the center line represents the median. Now the first question is, find the median time. Now here let us first see what is the value in between 9 and 10. So each division is going to be 0.2 because it is 9, this is 9.2, 9.4, 9.6, 9.8 and then comes 10. So this median is between 9.2 and 9.4. So it has to be 9.3 seconds. So this is our median value. Next we have to find the interquartile range. The formula for interquartile is Q3, which is upper quartile, minus Q1, which is the lower quartile. Now from this box and whisker plot, we can see that this upper quartile line is 11.2, 11.4, 11.6. So upper quartile is 11.6, we have written here. And lower quartile, this line represents the lower quartile. This is 8.2. So 11.6 minus 8.2, that will give us the value of interquartile range as 3.4 seconds. Now moving on to the next question. Find the difference between the average speed of the fastest car and the average speed of the slowest car. Give your answer in kilometers per hour. Now here, the fastest car takes the shortest amount of time to travel 195 meters and the slowest car will take the longest amount of time to cover 195 meters. So this line represents the fastest car because it has taken 6 seconds to cover 195 meter, and this line represents the slowest car because it has taken the longest amount of time to cover 195 meters. And the formula for speed is distance over time. So here we have written average speed of the fastest car is, distance was given in the question as 195 meters, over the time taken by it is 6 seconds, and this is in meters per second because 195 was given in meters and this plot is given in seconds. So this is in meters per second, but we need the answer in kilometers per hour. So to change this meters per second into kilometers per hour, we have to just multiply this meters per second with 18 over 5. So when you multiply these two together, you get the average speed of the fastest car as 117 kilometers per hour. Now following the same steps, let us find out the average speed of the slowest car. So distance remains same, that is 195 meters, and the time taken by the slowest car is 13. So 195 over 13 meters per second. Again multiply this meters per second with 18 over 5. That will give you the answer in kilometers per hour. So we got here 54 kilometers per hour. Now we have to find out the difference between the average speed of the fastest car and the slowest car. So here we have done 117 minus 54 and this will give us 63 kilometers per hour. Now moving on to the big question. Matilda records the distances that 80 different cars can travel with a full tank of fuel. The table shows this information. So here we can see that 7 cars can cover a distance of 250 to 300, 13 cars can cover a distance of 300 to 400 kilometers and so on. The first question is, write down the class interval that contains the median. Now to find out the median, take the given frequency of the cars here, total frequency, and divide it by 2. Since median is asked, we need to divide 80 by 2. So we get the value as 40. Now this is not the median, you need to do one more step. You need to keep on adding the frequencies of the cars till you get a value of 40 or a value which is more than 40. So here 7 plus 13, you get it as 20. 20 plus 19, it is 39, still lesser than 40. Now here 39 plus 21. Now this is the class interval where we get a value which is more than 40. So this becomes our median class. So we have written the same class interval over here. Now second question, calculate an estimate of the mean. Now to find out the mean, we have to find out the midpoint of each of the class interval and multiply that midpoint with its respective frequency. So for this class interval, the midpoint is 275. So to find out the midpoint, you can add the upper limit with the lower limit and divide it by 2. That is 300 plus 250 divided by 2. It will give you 275. So here we have taken the midpoint 275 and multiplied with its respective frequency, that is 7. Then add with the next ones. So again take the midpoint, that is between 300 and 400, you get 350, and multiply it with its frequency. So we are going to repeat it for rest of the class intervals. So we have written here. Now after doing that, we have to divide it by its total frequency, which is 80. So here we have made use of this formula, that is summation f of x over summation f. So summation f of x is midpoint of this class interval multiplied with frequency divided by total frequency is 80. Now simplifying this, we get the value of numerator as 32,900 over 80 or 411.25 kilometer. So this is our mean. A histogram is drawn to show the information in the table. The height of the bar for the interval 250 to 300 is 2.8 centimeter. Calculate the height of the bar for each of the following intervals. And the intervals asked over here are the second, the third and the fourth. So we have to find out what is the height of these three class intervals. So let us begin by finding the frequency density of each class interval first using the formula frequency density is equal to frequency over the class width. Now frequency is already given over here. To find out the value of class width, we take the upper limit minus the lower limit. So it's the difference between these two limits. So let us find out the frequency density of the first class interval using this formula. So here the frequency is 7 for the first class interval divided by the class width is 300 minus 250, that gives us 50. So 7 over 50 will give us 0.14. So this is the frequency density of the first class interval. So let us write here 0.14. Now similarly, let us find out what is the frequency density of the second class interval. So here we are going to first take the frequency, which is 13, divided by class width, that is 400 minus 300 is 100. So this will give us 0.13. Frequency density of the second class interval is 0.13. Using this formula, let us find out these two as well. For the third class interval, we get it as 0.95 and for the fourth one, it is 0.7. So we have got the frequency density of all these class intervals. Now the next thing is we need to find out the height of the bars. Now here the relationship between the frequency density and the height is, let us consider the first class interval. So here let us write frequency density and the height. So here the frequency density of first class interval was given as 0.14 and the height of the first class interval was given as 2.8. So now let us try to find out what is the height of the second class interval if its frequency density is 0.13. So this is a kind of cross multiplication relationship we have created. So let us see what is the height of the second class interval. So cross multiplying 0.13 multiplies with 2.8 and this gets divided by 0.14. So let us see how much we get here. So this will give us the value as 13 over 5 or in decimals it is 2.6. So we have got the height of the second class interval as 2.6. Now using this same format, we are going to find out the height of the third and fourth interval. So let me write here for the third interval. So for the first class interval, the frequency density was 0.14 and the height was 2.8 as it was given. Then for a frequency density of 0.95 for the third interval, let us see how much is the height. Now again cross multiplying, 0.95 multiplies with 2.8 and gets divided by 0.14. Let us see how much height we get here. So here we get the answer as 19. So the height of the third class interval is 19. Now let us use the same relationship again. So here we are going to remove this class interval and here as well and find out what is the height. So now for this class interval, the frequency density was 0.7. So it multiplies with 2.8 and gets divided by 0.14. So this gives the height of the next interval, which is 14. So here it is 14. Now moving on to the next question. 2 of the 80 cars are chosen at random. Find the probability that with a full tank of fuel, one of the cars can travel more than 450 km and the other car can travel not more than 300 km. This is a probability question and it is given that 2 cars are chosen at random out of the 80 cars. So let us write here 2 since 2 cars are chosen. Now the other thing they have given is one of the cars out of these 2 cars can travel more than 450 km. Now here if you look at this table, these are the distance covered by the number of cars. It is like 7 cars have traveled between 250 and 300 km and so on. Now here if you look at this last part of this table, 20 number of cars have traveled between 450 and 500 kilometers. And if we go to the class interval just before it, 21 cars have traveled between 420 and 450, which means these are the number of cars that can travel more than 450 kilometers. So here we are going to write 2 multiplied with, let us take 20 number of cars out of 80 that have traveled more than 450 kilometers, multiplied with. Now the next condition is the other car can travel not more than 300 km, which means look at the second class interval. This is between 300 and 400, which means it goes beyond 300 or above 300. But we want not more than 300, which means 7 number of cars have traveled between 250 and 300 or lesser than 300. So we are going to take these number of cars 7. And since 1 car we have already taken over here out of the total 80, here the total number of cars will reduce and it will come down to 79. That is 80 minus 1, that is 79. You can also write it as the other way round. That is, we are going to take 2 cars multiplied with, let us take 7 cars out of 80 which have traveled lesser than 300 kilometers, and there are 20 number of cars out of 79 which have traveled more than 450. So either this combination you can consider or you can consider this combination. So I am going to consider the first combination. So let me just remove this one and let us see how much value this gives us. So this is equal to 7 over 158. So let us write here 7 over 158. So this is the probability that satisfies the given condition. Let us move on to the next question now. Now the fifth question is a combination of vectors, graphs and mensuration chapter. Fifth A belongs to the vectors. P is a point with coordinates 1, 7. Q is a point 5, -5. Find the length of the vector PQ as a column vector, as we can see over here. So let me first mark up these coordinates on the graph given. So P is marked as 1, 7. Q is 5, -5. And this origin I have taken the coordinates as 0, 0. Since we have to find out the vector P to Q, so it is this way. The vector is going from P to Q. We are going to take the final position, that is Q, minus the initial position to get the value of vector PQ. So here we are going to write vector Q minus vector P is equal to, now rearrange this given coordinates as a column vector since the answer is asked as a column vector. So 5, -5, this represents your x value and this represents your y value, minus vector P is 1, 7. So here we are going to do 5 minus 1 gives you 4 and minus 5 minus 7 gives you minus 12. So this is the column vector representation of the vector PQ. Now moving on to the next one. Show that the magnitude or absolute value of vector OP is equal to the absolute value or magnitude of vector OQ. OP is the position vector of P, that is if you connect from O to P. So I have drawn here OP is the position vector of vector P and OQ is the position vector of Q. Now here we have to find out that the absolute value or the magnitude of OP is equal to the magnitude of OQ. Now remember that if a vector in general, if it is given this way, to find out the magnitude of vector P, we are going to square root the square of its x value plus square of its y value. So this in general represents the magnitude of the given vector. So using this formula, let us first write down the absolute or the magnitude of vector OP. So here you can see we have taken the magnitude of OP vector and using the formula square root of x square plus y square. Now the x and y coordinate of P was 1, 7. So we have squared 1 plus squared the y value, which was 7. So 1 square plus 7 square gives us square root of 50. Now using the same formula for the magnitude of the vector, we have found out the magnitude of vector OQ. So square root of its x coordinate was 5, so 5 square, plus its y coordinate was negative 5, so negative 5 square. This will again give us the value as square root of 50. You can see their values are same. So now we have proved that magnitude of OP is equal to the magnitude of OQ vector. PQ is a chord of a circle with center O. Calculate the circumference of this circle. So let us try to understand this question using a rough figure. So this is a circle with center O and PQ is a chord to this circle and the coordinates of P and Q are written over here. We need to find out what is the circumference of this circle. Now chord is a line which touches any 2 points on a circle. So from point O to point P, if we connect, this represents the radius and we have already found out the magnitude of OP in the previous part of this question and it was square root of 50. So this actually becomes the radius of this circle. So here we have written OP is the radius and it is square root of 50. Now once we have got this, let us write down the circumference of the circle formula, which is 2 pi r. R represents the radius. So here we have considered the radius as OP. You can also take it as OQ, but here I have considered OP. So 2 pi times square root of 50, its value, that will give us the circumference of the circle as 44.43. Now moving on to the next question. PQ is the diameter of a different circle with center R. Find the coordinates of R. So again I am going to draw a rough diagram over here. So this is a different circle with PQ acting as a diameter and R is the center of this circle and the coordinates of R I have taken here is x, y and the coordinates of P and Q will still remain the same. Now since R is acting as the center of the diameter, R becomes the midpoint of this line PQ. And we have the formula of midpoint as x1 plus x2 over 2, y1 plus y2 over 2. So this is the midpoint formula. Now we are going to add the x coordinates of the points P and Q. So 1 plus 5 we have written over here divided by 2, add the y coordinates 7 plus minus 5 over 2. 1 plus 5 gives us 6, 6 divided by 2 is 3 and 7 minus 5 is 2 and 2 over 2 is 1. So this is the coordinate of the point or the center of the circle R, that is 3, 1. Moving on to the next one. Find the equation of the perpendicular bisector of PQ. Give your answer in the form of y equal to mx plus c. Now here we have to consider the line PQ and there is a perpendicular bisector of PQ. Perpendicular bisector is a line which cuts the line PQ into 2 equal halves and it makes a 90-degree angle with the line PQ. So here we have drawn the line AB and it cuts the line PQ into 2 equal halves, which means M represents the midpoint of the line PQ. And we had already got the midpoint of the line PQ over here as R and it was 3, 1. So we have written here M. Here we have considered the midpoint as M, 3, 1. Now we have to find out the equation of this line AB in the form y equal to mx plus c. Now here we know the coordinates of the point P and point Q. So let us make use of the formula for finding slope of the line PQ. So the formula for finding out the slope is y2 minus y1 over x2 minus x1. Remember, you can also write it as y1 minus y2 over x1 minus x2. Both the formulas are correct. Now here I have considered x2 and y2 for Q and x1 and y1 for P. So substituting their respective values, y2 is negative 5 minus y1 is 7 over x2 is 5 and x1 is 1. So minus 1. So minus 5 minus 7 gives us negative 12. Over 5 minus 1 gives us 4. So negative 12 over 4 gives us the gradient or slope of the line PQ as negative 3. Now once we have found out the gradient or slope of line PQ, let us find out the gradient or slope of line AB. Now we have a condition when two lines are perpendicular to each other, the slopes of these two lines will multiply together to give us negative 1. So I have written here the slope of line PQ times the slope of line AB, which are perpendicular to each other, will be equal to negative 1. Now slope of line PQ we know it is negative 3 multiplied with MAB, that is slope of line AB, equal to negative 1. Taking negative 3 on the other side of the equal to sign, we get negative 1 over negative 3, and cancelling the negatives we get the slope of the line AB as 1 over 3. Now once we have got the value of the slope of line AB, it becomes easy for us to find out the equation of the line in the form y equal to mx plus c. Now keep in mind the value of this center point, the midpoint m, that is 3, 1, because the line AB is passing through this point. So the formula we are going to make use here is y minus y1 is equal to MAB x minus x1. Now I have redrawn this figure over here for easy reference. Since the line AB is passing through the points 3, 1, this becomes our x coordinate and this becomes our y coordinate, or x1 and y1 in this case. So y minus y1 equal to mx minus x1. Remember, this is the formula you can use to find out the equation of the straight line. So y minus y1 in this case is 1 equal to the slope of line AB, we got it as 1 over 3. So we have written here 1 over 3 times x minus x1 is 3. Now here y minus 1, the left hand side remains the same. We are going to expand the right hand side. So 1 over 3 times x gives us 1 over 3x, and 1 over 3 times negative 3 gives us 1 over 3 times 3. Now here the negative 1 let us transfer on the right hand side. So we get y is equal to 1 over 3x. Now this 3 and this 3 divides each other, giving you negative 1, and negative 1 goes on the other side and becomes positive 1. Now negative 1 and positive 1 will cancel out each other, giving us the equation of the straight line AB as y equal to 1 over 3x. Now let us move on to the next one. The position vector of A is A, the position vector of B is B, M is a point on AB such that AM is to MB is 2 is to 3. Find in terms of A and B the position vector of M. Give your answer in its simplest form. Now to understand this question, I have drawn a rough figure over here. O is the origin from which the position vector of A is drawn. That is, OA represents the position vector of A. OB represents the position vector of B. So it is marked as small a and small b. And M is a point on AB. You can see I have marked M over here. And it is placed in such a way that it divides AB in the ratio 2 is to 3. Now here I have written for AM 2 over 5. Because in this ratio, total number of parts are 5. That is 2 plus 3 is 5. So out of that, AM makes 2/5 of AB and MB makes 3/5 of AB. So here AM represents 2 over 5 of AB and MB represents 3/5 of AB. Now once we have drawn this, we have to find out what is the position vector of OM in terms of A and B. So before we can proceed, let us just try to find out the vector AB. Since we are trying to find out the vector AB, let me mark the arrow this way. Now remember that we have to add all the vectors which are going in the same direction. So here you can see OA and AB are going in the same direction. There is a continuity in the arrow, or there is a continuity in the direction. So here I am going to write vector OA plus vector AB will be equal to the sum of the vectors moving in the opposite direction. Now in this triangle, OA and AB were in the same direction, but OB is going in the opposite direction. And since there is just one vector moving in the opposite direction, we can just write here is equal to OB. Now OA vector is given as small a and AB vector we do not know, so let us keep it as AB vector, and this will be equal to OB vector which is given as B. So AB vector will be equal to B minus A, taking A on the other side of the equal to sign. Now once we have got AB, let us try to find out the position vector of M. So the position vector of OM is drawn, and in place of AM you can see I have written 2/5 of AB. We know that AM is 2/5 of AB and AB we got it as B minus A. So we are going to write it as 2/5 of AB, which is 2/5 of B minus A. Now the same thing I have written for MB as well. It is going to be 3/5 of AB or 3/5 of B minus A. Now once we have got this, either we can concentrate on the triangle OAM or we can concentrate on the triangle OBM to find out the position vector of M. Now I'm going to concentrate only on the triangle OAM. Now again remember that the vectors which are moving in the same direction will be added together and the vector moving in the opposite direction will be on the other side of the equal to sign. So here OA and AM are going in the same direction. There is a continuity in the direction. So I'm going to add these two. So here you can see I have written vector OA plus vector AM is equal to now the opposite vector, that is OM. Now OA is represented as small a plus AM we have already got it as 2/5 of AB, that is 2/5 B minus A is equal to OM. Now we are going to expand this bracket, that is 2/5 multiplies with B, giving us A plus 2/5 times B, and again 2/5 multiplies with negative A, giving us negative 2/5 A is equal to OM. Now A and minus 2/5 A are like terms. So this is 1A and this is minus 2/5 A. So basically we are going to just take the numbers, that is 1 minus 2/5, that will give us 3/5. So it is going to be 3/5 A. So our answer will reduce as OM is equal to 3/5 A plus 2/5 B. Now this answer is in its simplest form. So this is going to be our final answer. Now let us move on to the next question. Now the sixth question is from bearings chapter or trigonometry. The diagram shows the positions of two lighthouses A and B, a boat C and a harbour H. C is due east of B. Find the bearing of the harbour from the boat C. So we need to find out, if we are standing at point C, how much we need to turn in the clockwise direction to reach the line which touches the harbour H. So let me draw a north line over here first. So here we have drawn a north line at point C. Now there is a 90-degree angle between the point B and the north of point C. Now we have to keep turning around till we reach the line which is touching H. So we have drawn this arrow. Now the total angle made at point C is going to be total 360 degree. So if we subtract this 90 degree and 25 degree from 360 degree, this total angle, then we will be able to find this angle. So we can write here total 360 degree minus the 90 degree minus the 25 degree will be equal to 245 degree. So this angle, that is the bearing of the harbour from point C, is going to be 245. Now the next question is, show that the angle CBH is 100 degree. So for that let us consider the triangle CBH. Now I have highlighted this triangle. We know that from angle sum property of a triangle, all the angles of a triangle will add to 180 degree. So here we can write angle B plus angle H plus angle C is equal to 180 degree. Now let us take angle H and angle C as we have their values on the other side of equal to sign. So we get angle B or angle CBH is equal to 180 degree minus angle H minus angle C. Now substituting their respective values, we get 180 minus 55 minus 25 is equal to 100. So we have shown that the angle CBH is equal to 100 degree. Now the next question is, show that BH is equal to 13.7 kilometer, correct to 1 decimal place. Now here, to find out the value of BH, let us again consider the triangle CBH. So I have highlighted this triangle, and in the previous question we had got the value of angle B as 100 degree, which is written over here. Now since we need to find out the value of BH, which is a side, we can make use of sine rule over here. Now here angle B is opposite to the side CH, so this angle is opposite to this side, and since we need to find out BH, the angle opposite to this side is angle C. So the sine rule is side A over its opposite angle of sine A is equal to side B over its opposite angle sine B, and there has to be third one as well, equal to C over sine C. Now here we have just considered A over sine A equal to B over sine B. Now here let us keep A as our side BH over the angle opposite to side BH is sine C, and here we have considered B as the side CH and the angle opposite to this side is sine B. So we can write here BH over its opposite angle, sine of angle C, is equal to CH over the angle opposite to it, which is sine of angle B. Now here let us substitute their respective values. Since we have to find BH, let us keep it as it is. So BH over angle C is 25, so sine of 25 equal to CH is given as 32 km over sine of angle B, which is sine of 100. Now taking sine of 25 degree on the opposite side of equal to sine, we get BH equal to 32 times sine 25 over sine 100. So this will give us the value as 13.73 km. But since we have to round it to one decimal place as given in the question, we are going to round it as 13.7 km. So this is what we have got, and we have shown that BH value is 13.7 km. The next question is calculate the bearing of A from B, which means if we are standing at point B, at the north of point B, we have to keep turning in the clockwise direction and connect it to the line which joins point A. So we need to find out this angle now. Now here, so this is going to be 90 degree, and in part 2 of this question we had got the value of angle B as 100 degree. So we have 90, we have 100. Now we have to find out only this angle, that is angle ABH. So let me highlight this angle now. So I have highlighted this triangle where we have to find out this angle ABH. And in the previous part of this question, we had also got the value of side BH as 13.7 km. Now if we take this triangle ABH, we have the value of side AB, side AH and side BH. There is a missing angle, which is angle ABH. So here we can make use of cosine rule. So let me write here. Now the cosine rule is cos of the angle which we need to find. So cos of angle B is equal to, now take the sum of square of the two sides which is enclosing this angle B. So it is going to be AB square plus BH square. Now subtract the square of the side which is opposite to the missing angle. So here the side opposite to angle B is AH. So we have written here minus AH square. Now whole thing divided by 2 times. Now the two sides multiply together which are enclosing angle B. So 2 times AB times BH. Now we are going to just plug in their respective values. So AB is going to be 11. So 11 square plus BH is 13.7. So 13.7 square minus AH is 14. So it is 14 square. Divided by 2 times 11 times 13.7. Now let us see what value this gives us. So this is going to be equal to 0.37388. So I'm going to round it to 4 decimal places since this is an intermediate step. So in the intermediate steps, make sure that you're taking at least till 3 decimal places or 4 decimal places. So rounding this, I'm going to write. So we have rounded it and written it as cos B is equal to 0.3739. Now taking cos on the other side of equal to sine, we get angle B is equal to cos inverse of 0.3739. Now cos inverse of this value will give us 68.0435. So rounding it to 4 decimal places, we have written here angle B as 68.0437 degrees. Now once we have got this value, we have to just add the values, that is 90 degree, this 100 degree and the angle ABH to get the total bearing of point A from point B. So here we are going to add 90 plus 100 plus 68.0437 which we got just now, and that will give us the value as 258.0 degree. I have rounded this to just 1 decimal place. Now moving on to the next question. At 1 p.m. boat C sails 32 kilometers directly to the harbour at the speed of 10 knots. Calculate the time when the boat C arrives at the harbour and give this time correct to the nearest minute. And the value of 1 knot is given in terms of kilometers per hour. That is 1 knot is 1.852 kilometers per hour. Now since here we need to find out the time, the speed is given and also the distance is mentioned, we are going to make use of the speed, distance and time formula. So speed is given as distance over time, but since we need to find out the time over here, we are going to exchange the places of speed and time. So we will get time is equal to distance over speed. Now distance was given as 32 km and speed, since it is mentioned in knots, 10 knots, we are going to convert it into kilometers per hour. Since 1 knot is given as 1.852 kilometers per hour, 10 knots is going to be just multiply 1.852 by 10. So that will give us 18.52 kilometers per hour. So in place of speed we have written 18.52. Now since we have to convert it into the nearest minute and the speed is given in hours, we have to just multiply this fraction by 60. That is converting these hours into minutes. Now this will give us the value as 103.672. Now this is the total number of minutes. Now here we need to find out how many hours are there and how many minutes are there in this given number. Remember, this is in minutes. Now in 1 hour we have 60 minutes. So here we have just taken 1 hour out of it. So we have written 1 hour. Now out of 103.672, how many minutes are remaining? Because 60 minutes are gone. So we are going to just subtract the 60 minutes which we had taken for 1 hour and going to subtract it from 103.7. I have just rounded off this figure. 0.672 I have rounded to 0.7. So this will give us the remaining minutes as 43.7 minutes or approximately equal to 44 minutes. So converting this 103.672 minutes into hours and minutes, we get it as 1 hour 44 minutes. Now once we have got this, the question asks us at what time does the boat reach the harbour. Now it had left at 1 p.m. So we have to add this 1 hour 44 minutes to 1 p.m. to find out at what time it reaches the harbour. So here we have done 1 p.m. plus 1 hour 44 minutes. Just add the hours. 1 plus 1 gives you 2. So 2.44 or 2:44 p.m. This is when the boat C arrives at the harbour. Calculate the distance of boat C to the harbour when boat C is at the shortest distance from lighthouse B, which means this boat C is travelling to reach the harbour at H, and it reaches at such a point that it is at the shortest distance from point B. Now remember that the shortest distance is got when the point C is at 90 degree with the point B. So it is going to be this way. It has to make a 90 degree angle to get the shortest distance. Now since we have got the shortest distance, the boat has come over here and is at a shortest distance from point B. We need to find out CH, that is the distance of the boat from the harbour. So for that, let us consider the right angle triangle BCH. Now in previous part of this question, we had got the value of BH as 13.7. So I have written it over here. Now this is a right angle triangle. We need to find out CH. So we are going to make use of one of the trigonometric ratios. Now this angle H is 55. So the side opposite to the given angle will be always the opposite side. The side which is opposite to the 90 degree will be always the hypotenuse. So BH is the hypotenuse and BC is the opposite side. And the remaining side CH becomes the adjacent side. Now here, since we need to find out CH, we are going to consider the adjacent side and we have the value of the hypotenuse. So we are going to make use of the cosine trigonometric ratio, which is, in general, the cos theta is given as adjacent side over the hypotenuse. In this case, our theta is our angle H. So cos H is equal to adjacent side is CH and the hypotenuse is BH. Now substituting the respective values, we get cos 55, because H is 55 here, is equal to CH over BH is 13.7. Now let us take 13.7 on the other side of the equal to sign. So it multiplies with cos 55. So we have here CH is equal to 13.7 times cos 55, which will give us the value of CH as 7.857 kilometer. So we have found out the distance of the boat from the harbour. The diagram shows a box in the shape of a cuboid. The box is open at the top. Work out the surface area of the inside of the open box. Now here a cuboid is given which has some length, some width and some height. Now we have considered 70 cm as the length, 30 cm as the width and 40 cm as the height. And another thing they have given over here is the box is open at the top. So we do not have any surface which is enclosing this cuboid. Now we have to find out the surface area. Surface area is the sum of areas of all the faces of the cuboid. Now here, since the cuboid is open at the top, we do not have any face over here. It's an open box. So to find out the surface area, let us first consider the front face of this cuboid and the back face. Now this is a rectangle and it has length and it has height. So the area of this rectangle is going to be length times height, And since there are two faces, that is front face and the back face, we have written here 2 times length times height. Now for the second case, we have considered the right face and the left face. Now here this is also a rectangle, so area of rectangle is going to be the height times width. And since there are two faces, that is on the right and one is at the left, we have written it as 2 times width times height. Now the next thing is the top face and the bottom face. And since the top face is not present as it is an open box, we are going to consider only the bottom face of this cuboid. And the dimensions of the bottom face is length times width. So here we have written length times width only once. Now once we have got the areas, we are going to add them together. Now here the next step is substitution of their respective values. So we have 2 times length is 70 times height is 40 plus 2 times width is 30 times height is again 40 plus 70 times 30. Now this will simplify as 5600 plus 2400 plus 2100, which will add up together to give you 10,100 centimeters square. Now in part 2 of this question, it's given that cylinders with height 20 centimeter and diameter 15 centimeter are placed in the box. Work out the maximum number of these cylinders that can completely fit inside the box. Now I have considered the same cuboid which was given in part 1 of this question. Now here they have given the dimensions of some cylinders. The cylinder has a height of 20 centimeter and the diameter of that cylinder is 15 centimeter. Now we have to find out how many maximum number of these cylinders will fit inside this box. So for that, let us consider the length, the width and height of this box and also the dimensions of the cylinder, starting with the length of the cuboid. Now if we are trying to fit this cylinder inside this box, let me just show you an example. It's going to be fit this way. So if we are looking at these cylinders, the diameters will actually represent the length of this box. So here we have taken 15, that is the diameter of the cylinder, times we do not know how many cylinders will fit to this length, so we have considered it as x, will be equal to the total length of this cuboid, which is 70. Now here x will be equal to 70, 15 goes on the other side of the equal to sign, so we get 70 over 15 and this will be equal to 4.666. Now here we are going to approximate it as maximum 4 because 4.66 cylinders cannot be fit in the length, it's a decimal value. So we are going to take the lowest integer, that is 4 cylinders will easily fit for the length. Now we are going to do the same thing for the width. Now again we are going to fit the cylinders this way for the width. So we have to again check the diameter will be equal to 30. So we have written here 15, which is the diameter of the cylinder, times y. Y again represents the number of cylinders that can be fit to the width, is equal to the total width, which is 30. So y will be equal to 30 divided by 15, which tells us that 2 cylinders can be kept for this width. Now comes for the height. Now here again we need to check how many cylinders can be kept. So that represents your height. Now since here we are considering the height, we are going to consider the height of the cylinders as well. So here the height of the cylinder is 20. So we have written here 20 times z. Z again represents the number of cylinders that can be fit to the height of this cuboid, will be equal to the height of the cuboid, which is 40. So z will be equal to 40 over 20, which is 2, which means 2 cylinders can be easily kept on top of each other for the given height of the cuboid. Now since we need to find out the maximum number of cylinders that can be placed within this box, we are going to multiply the number of cylinders we have got for the length, for the height and for the width. So we are going to multiply 4 times 2 times 2, and that will tell us that 16 cylinders can be easily fit within this given cuboid. A solid bronze cone has a mass 750 grams. The density of the bronze is 8.9 grams per cubic centimeter. The ratio of the radius of cone is to height of the cone is 1:3. Show that the radius of the cone is 2.99 centimeter. Correct to 3 significant figures. A formula relating to density, mass and volume is given. That is density equal to mass divided by volume. Now here we are going to start by making use of the first piece of information, that is mass and density of the cone. Now here the formula is given as density is equal to mass over volume. And since we need to find out the volume, we are going to exchange the places of density and volume. So we get the formula as volume of cone is equal to mass over density. Now the mass is given as 750 and the density as 8.9. So we have written it over here. Now we will keep it as it is. Now the next piece of information is the ratio of radius is to height is given as 1:3. Now the same ratio we can also write it as a fraction, that is r over h is equal to 1/3. Now cross multiplying, 3 multiplies with r and h multiplies with 1, giving us h is equal to 3r. Now the next piece of information is taking into consideration this formula. So volume of the cone is given as 1/3 pi r square h, and volume of the cone we have got it as 750 over 8.9. So substituting over here, we have written 750 over 8.9 is equal to 1/3 times pi times r square times, now in place of height we are going to write it as 3r. Now we are going to replace h here because we have to show that r is equal to 2.99. So we are going to replace h with r. Now once we have done this, let us take all the constant terms from the right hand side to the left hand side. So we get here r times r square gives us r cube is equal to, now here this 3 multiplies with 750. So 750 times 3 divided by 8.9. Now the pi goes on the other side and multiplies with 8.9, and same thing happens with 3 as well. Now 3 from the numerator divides 3 from the denominator, and taking the cube on the other side of equal to sign, it turns into the cube root. So r will be equal to cube root of 750 over 8.9 times pi. Now let us see how much value we get here. So this will give us the value as 2.993, and since we have to round it to 3 significant figures, we are going to take it as 2.99 centimeter. So we have shown that the radius of the cone is 2.99. Now the second part of this question is calculate the total surface area of the cone, and the curved surface area of the cone is given by the formula A is equal to pi r L. Now r represents the radius and L represents the slant height. Now we do not have the value of slant height, we need to find it. So for that we are going to make use of the data which was given in previous part of this question. That is, height we had got it as equal to 3 times the radius, and radius value we had got it as 2.99. So 3 times 2.99 gives us 8.97 centimeter. That is the perpendicular height of this cone. Now this is the base radius which we have its value as 2.99, and this is the slant height. And if you look carefully at this cone, this represents a right angled triangle. So we are going to make use of Pythagoras theorem, that is hypotenuse square, the slant height square, equal to the sum of square of rest two sides of this triangle, that is h square plus r square. Now taking the square on the other side of equal to sign, we get the slant height L is equal to square root of h square plus r square. H we got it as 8.97, so we are going to square it, plus the radius is 2.99. So we are going to square it. Now this will give us the value of the slant height as 9.455 centimeter. Now here we need to find out the total surface area of this cone. And total surface area is made up of the curved surface area plus the base area, which is a circle. So here we have written total surface area of the cone is curved surface area of the cone plus the base area, which is a circle. Now formula for curved surface area is already given as pi r L, and the base is a circle. So we have made use of area of the circle formula, pi r square. Now substituting their respective values, that is pi times 2.99 times 9.455 plus pi times the radius is 2.99 square. Now solving this, we get the total surface area of the cone as 170 centimeter square. Now let us move on to the next question. Now the 8th question is from the graph chapter. On the axis, sketch the graph of y is equal to x square plus 7x minus 18. On your sketch, write the values where the graph meets the x-axis and the y-axis. Now here an equation is given, and this represents a quadratic equation because highest power of x is 2. So our graph is going to be a parabola. That is, either it is going to be a U-shaped graph or a N-shaped graph. Now to decide whether it is U-shaped or N-shaped, we need to look at the sign of the x square. If x square is positive, as it is in this case, the shape of the graph is going to be U-shaped. And if in the question it was given as minus x square, then it was going to be N-shaped graph. So here, since positive x square is given, we are going to stick on to this shape. Now once we have understood the shape of the graph, let us find out what all things we need to draw this curve. So here a rough figure of the U-shaped parabola is shown. Now we need to find out three important things when plotting the graph. First is finding the x-intercepts. These are the points made by the curve when it cuts the x-axis. So you can see I have marked 2 points over here as this curve cuts the x-axis at these 2 points. The second thing is finding the y-intercept. Now y-intercept is the same curve where it cuts the y-axis. So this curve is cutting the y-axis at this point. So I have marked here y-intercept. And the next thing is finding the vertex or the turning point. Now as we know the parabola takes a turn, it is U-shaped. Now this point where it takes a turn is called as the vertex or the turning point. So let us begin by finding the x-intercepts first. Now to find the x-intercepts, we need to make y is equal to 0 in this given equation. As we know the x-intercepts are on the x-axis, their y-coordinates will be 0. So we make y equal to 0. So this equation becomes 0 equal to x square plus 7x minus 18. Now we have to factorize this. That is, we need to find out the factors of negative 18, which when multiplied gives us negative 18. And when added gives us positive 7. So the factors we can think about here is 9 and negative 2. So if you multiply these two, we get negative 18. And when we add these two, we get positive 7. So we get two factors here, that is x plus 9, our 9 is positive here, and x minus 2. Now once we have got the factors, we directly get the x-intercepts. That is, take x plus 9 equal to 0. So x will be equal to negative 9 and x minus 2 equal to 0, and that will give us x equal to positive 2. So we have got the x-intercepts of the curve. Now the second thing is finding the y-intercept. Now when we are finding the y-intercept, we are going to make x equal to 0 because our y-intercept is on the y-axis where our x-coordinate is going to be 0. So taking x equal to 0 and plugging it in this equation, we get y is equal to 0 square plus 7 times 0 minus 18, and this will give us the value of y-intercept as negative 18. Now the last and final thing we need to find out is the turning point coordinates. Now I have taken this graph again over here, and one small additional data has been added, that is axis of symmetry. Now to find the vertex, we can make use of axis of symmetry. Now this is a line which divides this parabola symmetrically, that is into two equal halves. So if we are able to find out the x-coordinate of axis of symmetry, then that will be equal to the x-coordinate of the turning point, because the axis of symmetry passes straight through the turning point. Now we have a formula to find out the axis of symmetry, and it is straightforward, minus b over 2a. Now b and a represents the coefficient of this given equation. Now here it was given that y is equal to x square plus 7x minus 18. So a is going to be the coefficient of x square, which is 1. B is going to be the coefficient of x, which is 7. And C is going to be the constant, that is negative 18 in this case. Since in the formula we need just b and a, we are going to substitute the value of b as 7 and a as 1 in this formula. So axis of symmetry x, that is we are going to get the x coordinate now of this line, is equal to minus b. So minus b was 7 divided by 2 times a, which is 2 times 1. So this will give us the x coordinate, that is minus 7 over 2. Writing it as a decimal, we get it as negative 3.5. Now once we have got the x coordinate, we can find its y coordinate by plugging in the value of x in this given equation for y. Y is equal to minus 3.5 square plus 7 times minus 3.5 minus 18. So this will give us the y coordinate of the vertex as negative 30.25. So here we have the coordinates of vertex as negative 3.5, which is the x coordinate, and the y coordinate is negative 30.25. Now using all the three, let us draw the graph over here. So I have already drawn the graph. Here x-intercepts, we had got it as 2 and negative 9. So you can see I have marked on the positive x-axis positive 2 and on the negative x-axis negative 9. Y-intercept was negative 18. So you can see on the y-axis I have marked negative 18. And the vertex or the turning point is negative 3.5, and on the y-axis we have written minus 30.25. Now after plotting all the points, we are just going to draw a freehand curve joining all the points. Find the derivative of y is equal to x square minus 3x minus 28. Now derivative is the differentiation of y with respect to x. So here y becomes dy by dx, differentiating y with respect to x is equal to, now here x square, the power 2 comes down and it gets multiplied with x, and the power of x reduces by 1. So it becomes x to the power of 1. So we have used the power rule of differentiation over here. Now the differentiation of minus 3x becomes minus 3. If it was minus 5x, it was going to be minus 5, and so on. And the differentiation of the constant term will be 0. So here we can simplify and write the differentiation as 2x minus 3. This is our answer. Now the next question is, find the coordinates of the turning point of this given equation. Now whenever we are finding the coordinates of the turning point, remember that the turning point is also the stationary point of a given curve. So here if I draw a curve this way, this turning point is also your stationary point. And at the stationary point, you have its slope or gradient equal to 0. So basically we have to take dy by dx equal to 0 for this equation. And dy by dx of this equation we had already found in previous part of this question, which was 2x minus 3. So 2x minus 3 will be equal to 0 now. So taking minus 3 on the other side of the equal to sign, we get 2x equal to 3, or x is equal to 3 over 2. That is x equal to 1.5. So we have got the x coordinate of this turning point. We are going to plug in this value of x in y to get the y coordinate. So here we have written at x equal to 1.5, we get y is equal to 1.5 square minus 3 times 1.5 minus 28. So that will give us the y coordinate as minus 30.25. So the coordinates of turning point of this given equation is 1.5 and minus 30.25. Now moving on to the last part of this question, the line y is equal to 5 minus 2x intersects the graph of y is equal to x square minus 3x minus 28 at point P and point Q. Find the coordinates of P and Q. So for example, if our curve is represented this way, that is x square minus 3x minus 28, let's say that y is equal to 5 minus 2x, that is this line intersects, means cuts this curve at points P and Q. For example, in this manner. We need to find out what are the coordinates of these 2 points. Now if you see carefully, P and Q are the points where the curve is meeting the line. So if in the question it is given that the line intersects the graph, then we are going to take y of the line is equal to y of the curve. So it can be written as the y equation of the line will be equal to the y equation of the curve. So here we are going to write equation of line is given as 5 minus 2x equal to equation of curve is x square minus 3x minus 28. Now let us take 5 minus 2x on the right hand side. So we get x square minus 3x, minus 2x becomes plus 2x, minus 28, and plus 5 when we take on the other side becomes minus 5 equal to 0. Now simplifying this equation, we get x square minus 3x plus 2x gives us minus x, and minus 28 minus 5 gives us minus 33 equal to 0. Now this is a quadratic equation, and to get the factors of this equation I am going to use the quadratic formula, which is x is equal to minus b plus minus square root of b square minus 4ac over 2a. Now in this formula, a represents the coefficient of x square, which is 1, b is the coefficient of x, which is negative 1, and c represents the constant, which is negative 33. Now substituting the value of ABC in this formula, we get minus of minus 1 plus minus square root of b square, which is negative 1 square, minus 4 times a is 1, c is negative 33 over 2 times 1. Now simplifying this, we get minus of minus 1 gives us plus 1, plus minus, now square root reduces as square root of 133 over 2. Now this can be split up into 2 values, that is x equal to 1 plus square root of 133 over 2 and x equal to 1 minus square root of 133 over 2. Now here we get the value of x as 6.27 and minus 5.27. Now once we have got the values of x, let us find out the values of y coordinates by plugging in the x values in this equation or this equation. So I'm going to choose the easier equation, that is y is equal to 5 minus 2x. So here we have written y is equal to 5 minus 2x. Substituting first value of x as 6.27 in this equation, we get the value of y coordinate as minus 7.54. Next, taking the second value of x as minus 5.27, we get the value of y as 15.54. So the values of the two coordinates p and q are 6.27, negative 7.54 and negative 5.27, 15.54. Now the ninth question is from composite functions. F of x is given as 4x plus 1, g of x is 6 minus 2x, and h of x is 3 to the power of x minus 2. We have to find out f of 3, which means we need to make use of the function f of x. Now in place of x, they have given the value as 3. So we are going to replace all the x values by 3. So f of 3 is equal to, now this is 4 times x, so it becomes 4 times 3 plus 1. So 4 times 3 is 12 and 12 plus 1 becomes 13. So the value of f of 3 is 13. Now the next one is g of f of 3. That is the function f of x is within another function, that is g of x. Now the value of f of 3 we had already got it as 13. So here in place of f of 3 we are going to replace its value, that is 13. So we write it as g of 13 is equal to. Now since we are referring to the function g, in place of x we are going to replace everywhere 13. So this becomes 6 minus 2 times 13, that is 6 minus 26. It gives us the value as minus 20. So this is the answer. Now moving on to the next one, we need to find the inverse of g. So we are going to consider this function. Now here I have replaced g of x by y. So y is equal to 6 minus 2x. Now the first step is swap the places of x and y. That is, x takes the place of y and y will take the place of x. So here we have got x is equal to 6 minus 2y. Now once we get this, rearrange this equation to make y as the subject again. So I have taken minus 2y on the left hand side, so it becomes plus 2y, and x comes on the right hand side and it becomes 6 minus x. So y will be equal to, now sending 2 on the other side, we get 6 minus x over 2. So this will give us the inverse of g of x. So here we have written g inverse of x is equal to 6 minus x over 2. Now in the C question we need to find x when f of x is equal to g of 2x minus 7. Now f of x we have been given as 4x plus 1 is equal to, now in g of x, wherever we have x, we have to replace it with 2x minus 7. So here we have written 6 minus 2. Now in place of x, we are going to write 2x minus 7. Now the left hand side remains the same, that is 4x plus 1 is equal to 6 minus. Now we are going to expand this bracket, that is minus 2 times 2x gives us minus 4x and minus 2 times minus 7 gives us plus 14. Now let us gather the like terms, that is 4x and minus 4x will be taken on one side of the equal to sign. So minus 4x becomes plus 4x is equal to, now 6 plus 14. Now plus 1 will be taken on the right hand side and it becomes minus 1. Now 4x plus 4x gives us 8x equal to 6 plus 14 minus 1 gives us 19. So x will be equal to 19 over 8, which is equal to 2.375. So this is the value of x. Find the value of h of 2. Now we are going to start with the inner function first, that is h of 2. And h of x function is given. So wherever we have x, we are going to replace it by 2. So here we have written h of 2 is equal to 3 to the power of 2 minus 2. 2 minus 2 gives us 0. So 3 to the power of 0 is 1. So this inner function has the value of 1. So this has gone down to 1. So we are left with h of 2, which is equal to h of 1. Now again we are going to make use of this given equation, and in place of x we are going to put 1. So 3 to the power of 1 minus 2, that gives us 3 to the power of negative 1, or we can write it as 1 over 3, or in decimal you will get it as 0.333. So this is the answer. Now the last part of this question, Find x when h inverse of x is equal to 10. Now here we can take this h inverse on the other side of the equal to sign. So this given equation rearranges as x equal to h inverse changes to h. So we get h of 10. Now once we have got it in this format, we can just substitute the value of x as 10 in this equation to get the value of h of 10. So here we have written 3 to the power of 10 minus 2, that will give us 3 to the power of 8, and this will give us 6561. Now since x is equal to h of 10, we get the value of x as 6561. So this is the answer for this given question. I hope you have understood all the steps and liked the video. And if you found this video useful, then check out this playlist where you'll find more examples of this kind. And if you're liking my videos, like, share and subscribe to my channel. And thank you for watching.